So I'm going to give you the solution for this particular question by filling out this table. And as I said, take your time thinking about it and verifying your own intuition against what I'm presenting to you here. Now, what you'll find is that MCS link-based QLock and Anderson's array-based QLock are the two algorithms that do quite well on most of the different categories of attributes that I mentioned to you. But I should tell you that if you have fancy instructions, fancy read, modify, write instructions, then Anderson's and MCS lock give you the best performance on all these attributes. But on the other hand, if the architecture does not support fancy read, modify, write operations, and it only has test and set operation available, then some sort of a delay-based, either exponential delay-based or static delay-based spin lock algorithm may turn out to be the best performer. And in fact, when the amount of contention for lock is fairly low, it's best to use a spin lock with exponential delay. Start out with a small delay and keep increasing it. On the other hand, if it is a highly contended lock, then it is good to use a spin lock that has statically assigned delay spots for every processor. And one of the things that I also want you to notice is that the number of read, modify, write operations that you need to do for the different lock algorithms really depends on the amount of contention that is there for the lock in the case of spin algorithms. In the case of Anderson's and MCS, the number of atomic operation is always 1, regardless of how much contention there is. And of course, in MCS, there is a corner case that you have to worry about during unlocking that might result in an extra read, modify, write operation. But in the case of the spin algorithms, the amount of contention is really dependent on the number of read, modify, write operations that you have to perform per critical section. Really depends on the amount of contention that is there for the lock.